All right, guys, we're going to talk about the last way to solve a quadratic today. So kind of this is our last resort. If we are in standard form, we should always try to factor first. But if we can't factor and we kind of don't want to complete the square because like no fun, then the way that I have to solve is by using the good old quadratic formula right here. So a formula is just like basically an equation where I plug numbers in and it just tells me the answer. So like a more simple formula is like the formula for finding the area of the area of a rectangle. So if I'm trying to find the area of a rectangle, that's length times width or base times height. And so if I tell you the length is 5 and the width is 7, then we know the area is 35. You just take the numbers, plug them in, and it spits out the answer for you. That's kind of what the quadratic formula is, except it's a much bigger formula, okay? So essentially, this is going to tell you exactly what x equals or what the x-intercepts are, as long as I plug in my a, b's, and c's correctly and I follow the order of operations, okay? So kind of the order we want to go in is we need to do what's under the root first. Okay, so first under the root, and underneath that there's kind of an order as well. So we're going to do the squared part, then multiply 4 times a times c, then add or subtract, which I know sounds a little sus because like it says subtract right there. But if I do 4 times a times c and I end up with a negative number, then the double negative is going to make it a plus. If I end up with a positive number, then it's going to stay minus. Okay, so we kind of want to be careful about that. But we do like our b squared, then we multiply, and then we add or subtract. Second thing we want to do. Oh, Siri's listening to me. Siri, hush up, girl. We don't need you. Second, we want to take the square root, if possible, or we might end up birthday caking it or simplifying the root. Third, we want to do the negative b plus or minus part with our new number here. Again, if possible, so like if I am able to take the square root, then I want to add and subtract that number from negative b. And then kind of fourth, I wrote this too big, we want to divide by 2 times a, which should end me up with 2 unique answers, but we might end up with only one answer, or we might end up with no answers. So that could definitely happen. So kind of the best way to do it is to just do it. So I'm going to start with an example here. Actually, let's just jump right over to our book. Nope, I'm going to start with one right here. So if they want me to solve y equals 2x squared minus 3x minus 7, that is in standard form. We always first want to replace y with 0 because we're trying to find those x-intercepts, and that happens when y is 0. And we could try to factor first, and we probably should because usually factoring is easier to solve, but maybe we did and we couldn't do it or whatever, and we're kind of stuck with using the quadratic formula. So in that case, we want to identify our a, b, and c. And so a is always the number on x squared, b is always the number on x, and c is the number all by itself. You always want to take the signs with it. And then we just fill in our formula. So we have negative b, which will actually make that a positive 3, plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so then as I said, we're going to follow order of operations here. We're going to have to do what's under the root first, and under that root we want to square this. So negative 3 squared is positive 9. Anything squared is positive. And then kind of at the same time right now, I can multiply. Now, I know I said like multiply 4 times a times c, but really I multiply the -4 times the 2 times the -7. And so then I see that this is going to change to a plus 8 times 7, so 56, all over 4. I can kind of do that right now because it's not going to affect anything. Still under the root, there's stuff to do. And so we're going to add those up for 65 over 4. Then I'm going to square root the 65, but I know I can't because square root of 64 is right under that, and that's 8, so it's a little more than 8. But I could try to birthday cake it, although I'm pretty sure that it won't. 65, let's try it. 5 goes in, 1, 3 times, yeah, 5 times 13. 13 is prime, so I can't take anybody's out. So since I can't square root it, I can't really add and subtract it with the 3, and I can't really divide the 4. So this is kind of my final answer, and I do have 2 answers there, one when I add the root 65 and one when I subtract it. Okay, so kind of in our book here, we're going to try a few more. So our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's a nice little song. So this one here is almost in standard form. It's actually kind of in a way where I might want to complete the square, but I don't want to because I don't want to take half of 7. So instead, I'm going to make this equal to 0 so that we are in standard form. Plus, I also need to be equal to 0 if I want to solve anything. Then we want to find our a, b, and c. Now, again, we could try to factor this, but we want to practice the quadratic formula, so we're just going to jump right to it. So a is 1, b is 7, c is -6. And then we just want to plug in all the things into their formulas. So we'll have x is equal to negative b, so -7, plus or minus the square root of b squared. Now, once you start getting good at this, you can probably square the thing in your head. So 49 minus 4 times a, which is 1, times c, which is -6, all over 2 times a, which is just 2, because 2 times 1. Maybe I'm going to put the 1. Then I can simplify more under the square root. So we want to multiply over here, and I notice the negative is going to make it a plus. The 1 kind of doesn't matter, so really it's just 4 times 6 for 24, all over 2. Then up here we'll have x equals -7 plus or minus the square root of. We can add these things, so that's going to be 73 over 2, and 73 feels real prime. I think we might be done. Like, I don't think I can take the square root of 73. And so you can kind of leave your answer like this, or if you want to be more convinced that there are 2 separate ones, you could write them separately. So one with a plus in between and one with the minus in between. So you can see like, oh yeah, I do have 2 answers. Okay, let's try another. So looking at this one here, I definitely have to be equal to 0 first. Also, like I want it in standard form, which everything needs to be on the same side. So I am going to keep the x squared positive and subtract the 8x and add the 8. Now the other thing that I kind of notice right now too is that 2 goes into each of these, and so I'm going to divide that out because that'll just make my numbers all smaller, which is super nice. And we're trying to solve, so like that's totally legit. You can do that as long as they all divide by the same thing. And so now my numbers are much smaller. Oop. So a is 1, b is -4, and c is 4. It's just nicer to not work with smaller numbers. Okay. So again, I might be able to factor this. I'm just going to use a quadratic formula so that we can practice. So x is equal to -b. Oops, that's going to be +4 plus or minus the square root of b squared minus 4ac all over 2a. That goes the weasel. Anyways, so x equals 4 plus or minus the square root of 16. Over here, it's going to stay minus. 1 doesn't matter, but 4 times 4 is 16 over 2. Interesting. So we'll have x equals 4 plus or minus the square root of 0, which the square root of 0 is just 0. And like 4 plus or minus 0 is just 4. So really this just ends up being 4 over 2, which is 2. So I kind of only have one answer here, which again, that can happen when my vertex just bops right off the x-axis like that. So that's okay. That can happen. And then lastly, we got one more to try here. I want to make this equal to 0. I also kind of want to keep my x squared positive. So this time, I am going to add the x squared over, subtract the 2x over, and the 5 is going to stay. Then we'll find our ABC because these don't all have a thing in common, and the numbers are already pretty small, so that's not so bad. And again, I'd probably try to factor first, but if I can't figure it out, I'm going to jump to my quadratic formula. So x equals negative b, so positive 2, plus or minus the square root of b squared, which is going to be 4, minus 4 times a, which is 1, times c, which is 5. It's super tempting for people to want to subtract first, but I got to multiply first. Multiplication comes before subtraction, all over 2 times a. So x equals 2 plus or minus the square root of 4. I can tell that this is going to stay subtraction. And when I multiply up, we get a 20 all over 2. Then we have x equals 2 plus or minus the square root of, when I subtract here, we're going to have negative 16 over 2, which can't take the square root of a negative. So that kind of means I don't have any answers for now. So no solution for now. And we did unfortunately have to cover over this, but I do want to talk about this thing, the discriminant. So I know you probably glued over it. I'm going to write it on the back of this. The discriminant is another formula that helps me kind of know how many answers I'll have. Like if you notice, we did an example of each one. One where I have 2 answers, one where I have 1 answer, and one where I have 0 answers. And sometimes that's all I need to know. Sometimes all I want to know is how many answers do I have. Maybe I don't even care what they are. I just want to know how many. And so the discriminant can help me do that. The discriminant is b squared minus 4ac. So it's really not even a new formula. It's just the part under the root. And the reason that that helps me so much is because when I try to square root stuff, funky things can happen. If I square root a positive number, or a number bigger than 0, then that's fine. Like square root of 16, that's 4 and negative 4. Square root of 9, that's 3 and negative 3. So this one will always give me 2 answers. However, if you remember that second one we did in here, so that first one, that discriminant was 73, and that's how we got 2 answers. But the second one, when the discriminant was 0, I only had 1 answer, and that's because I'm adding and subtracting 0 from the same thing, which isn't going to change it, because 0 isn't going to do anything to the 4. And then the last situation is if I do the discriminant and it's a negative number or less than 0. That means I have 0 answers for now. And so that can be kind of helpful because if I just want to know how many solutions does y equals 3x squared minus 2x minus 1 have, I don't need to do the full quadratic formula. All I need to do is the discriminant. So I would do like b squared minus 4ac. So negative 2 squared minus 4 times A times C. And so we get 4 minus, nope, actually plus 12, so 16. And because this is a positive number, this tells me I have 2 answers. And then if they wanted me to know exactly what those answers were, I'm already like half the way done with my quadratic formula. So then I could just take this 16 and put it under the root and continue the formula out if you need to. So anyways, that's the quadratic formula. She's a real cutie. Discriminant is helpful as well. Good luck on solving your quadratics.